Through construction, it has to do a lot with the coordination of different disciplines. And this is maybe a good segue into the technology piece. It's not new from the instance that it didn't come out this year, but new in the grand scheme of things, the construction industry, the ability to 3D model everything. So your HVAC trades, your electrical trades, your plumbing, your structural, your architectural features with certain fur downs and millwork, the ability to design all of that in a software like Revit, where everything can be 3D modeled and coordinated, that alleviates a lot of those coordination issues downstream. 10 years ago, when that wasn't mainstream, or probably even less than that, you draw everything on paper in 2D lines, and whether or not it was AutoCAD or some people, I still know architects who draw on pen and paper, but you don't get an appreciation for things like beam depths and millwork elevations. So when you're trying to size ductwork and show approximate locations of duct run, and how does that coordinate with plumbing, right? If plumbing's on a separate page and that doesn't coordinate with MEP on some of these more complex, or mechanical on some of these more complex systems, you could end up with pipe and ductwork trying to occupy the same space. And if that isn't thought about ahead of time, it's a lot easier to coordinate. It's a lot more difficult to coordinate that in 2D when you're trying to, okay, well, this is the size of this ductwork, and I'm going to draw this, and we're going to mention that. How do we carry that chase through a project? So a lot of the construction delays really come when you actually start installing your MEP systems. Oh, well, this beam, this isn't a truss, this is actually a beam, and things like that should be figured out. But can we go below the beam? Is it a wood frame project? Can we notch it out to run some pipe through here? How much of a notch is too much? So it's a lot of the trade coordination items. Once you actually get there and, oh no, these two pieces of pipe run into each other, what do we do? That's a lot of that hang up. That's not necessarily in the final 10%, but that is a lot of the coordination questions that we get on projects that may not utilize some of the more effective or efficient technology that we have available today.
Okay. Yeah, that makes sense. And we're back to our episode of Breaking Ground with Daniel McCaulley. He is the founder and principal of Ultimus Engineering. Daniel, again, thanks for joining us. And we'll jump right into the theme of the show, innovation. And I know a lot of that comes with technology. So we'll start there. How has technology been changing engineering over the course of your career?
Yeah, it's been incredible over the course of the career, not just in the last 5 years that I've been running this company, but really the ability to, I think, visualize in a more true form the things that we build. And that's a very generic statement. And that's, again, everything from oil and gas tools to tennis shoes to cars to buildings and everything in between. The ability for someone to take something in their brain and formalize it in a way that other people can see and appreciate has been incredible. And it starts, again, it's everything from the 3D modeling for general manufacturing to the incredible rendering packages that are available today, so people can truly appreciate, again, things like whether it be exotic car design or even consumer products. The ability for people to take that vision and portray it in a way that other people can understand has been immense. And that also trickles down into engineering as well. And we touched on it briefly before the break, but the ability to fully 3D coordinate and model these systems that we're building. Buildings are not getting less complex. They're getting very complex. And as architects get more and more creative, and as our building materials get better, it only allows the architects to be more and more creative, which pushes the envelope of engineering. And there's a lot of cases where we have to be very creative with our engineering and solving these complex challenges that architects put before us, and we're excited and we love doing that. But the ability to create these visual models that make sure everything is well coordinated so we don't end up with construction issues later. Again, as projects get more complex, we'll talk about the structural engineering aspect of it. The software that allows us to run tens or hundreds of thousands of computations simultaneously rather than doing everything on pen and paper allows for projects to get done much quicker and be much more accurate and more complex, and just ultimately have more fun as we embrace the new technology and new softwares that are available.